get started now since people seem to stop filtering in, kind of. Yeah, good enough. Um, anyway, I'm curious, how many of you guys have actually considered deploying CSP anywhere? Yeah, a couple of you guys. Has anyone actually deployed it? Okay, well, if you need more discouragement, this is it. Um, before I get started, I've done a fair amount of web security research in the past, and this is kind of what led me to looking into content security policy. I'm not really the kind of person who's going to deploy it myself, so this whole talk is going to be from kind of, an attacker's mindset of what I do if I run into this while trying to, hack something. By day, I'm a security researcher at Coverity. We build static analysis software. We have a security blog where we post information such as this if you guys are interested. But more importantly for today, I'm someone with CSP bypasses. This talk is actually going to be one that I gave at RuxCon a couple of months ago, and it hasn't really changed since then at all. So if you saw it then, there's not going to be anything new, sorry. But the other thing that I just want to mention, last time I gave this talk, a lot of people kind of grilled me about cross-site scripting filters, and I've got nothing to talk about with regards to those. I'm just going to go over what CSP is, what can happen if you don't implement a complete policy, and what you as an attacker can potentially do if there is an incomplete or actually complete policy. And then I'll give some miscellaneous thoughts and defensive ideas that might be relevant from the attacks that we can see. So before I get started, I kind of want to acknowledge a bunch of people who've done interesting work either directly on CSP or have done the precursors to this when everyone was interested in bypassing NoScript, because we thought people actually used that. But yeah, a lot of great work has been done on this space in the past, and I'm kind of standing on the shoulders of giants, so I just wanted to give proper attribution to at least some of the people. So if you haven't heard of CSP before, the main thing it is an extra HTTP header that you can include in a website to try and act as a defense in depth mechanism, but which disables inline scripting or styles or unsafe eval and a bunch of other different configuration features that I'll go through in more detail. It also has a reporting mechanism for violations. People have talked about using this kind of as an IDS for cross-site scripting because you can get alerts when something like this fires. It's not super realistic to use it for that, but it exists. So yeah, when I say it's a HTTP header, it's specifically a response header. You add it into your HTTP response. In this example, the policy just says that the scripts can only come from the same domain. So self is the domain that this response is coming from. So that disallows things like inline scripts. So in this kind of response, if you have just a script alert and you have a CSP policy that says it's only allows scripts from the current domain, that means you need scripts with sources pointing to the current domain. So this will be blocked. And you'd get an error like this in Chrome. I killed all the demos because I don't have so much time this time, but if you want to see some demos, you can come talk to me afterwards. But this is what this CSP working would look like. You'd have a script and it wouldn't fire. So before I actually get into talking about what bypasses I found, I want to quickly note what a bypass would be. Since most of these bypasses don't actually let you execute script directly, they let you do something that's not script execution, but still useful. Specifically, the main thing that I looked at was what can you do to leak CSRF tokens, since often what you really want to do when you conduct an XSS attack is you want to force the user to do some kind of action. If you're attacking Gmail, you might want to set up like a mail forward or something that leaks all that user's email. To do that, all you need really is a CSRF token. Maybe Gmail's been updated, but you have these same kinds of things in banking applications. You might want to force someone to transfer their money to someone else, et cetera, et cetera. So In my mind, stealing CSRF tokens is almost equivalent to running JavaScript in a web context. It's slightly different for extensions and other things where you run JavaScript and you use CSP, but in a website context, CSRF tokens are pretty much the keys to the kingdom, or at least the user. So the simplest CSP directive that you have that you can put in a header is this image source directive. And the one thing that many sites seem to do is they have an image source of star. They say, hey, images aren't particularly sensitive. Let's allow them from all domains. So, that seems kind of safe because images don't do much besides show you stuff. But one of the very first attacks that kind of people thought of when thinking about non-scripting attacks was this kind of like half-open or like dangling markup attacks, where you inject some, in this example, you inject an image which has a source attribute that hasn't actually been closed. You'll note that there's no apostrophe at the end of it. And you inject that into a page which has CSRF tokens and then an apostrophe somewhere further down the page. When you force a user to make a request to the URL down below here, no, sorry. If you make a user make a request to an XSS with this red part injected, then what will happen is the user will see this website and they'll end up making a request to this log.cgi with the CSRF tokens in there. This is a little bit of a contrived example. You can say that, oh, not all sites will have apostrophes and these kinds of things, but these kinds of attacks get more advanced as people found more things that could be abused. And the first thing that people found was there are a bunch of tags that can kind of consume the rest of the page without needing anything to close them. The most obvious is this text area tag. If you have an XSS and you inject a form action to evil.com and then a text area, the web browser will include the rest of the page inside the text area tag. So when the form is submitted, when the form is submitted, the whole text area will be sent to the attacker server. So again, this is useful because you can steal CSRF tokens from within the page that you've got your injection on. And there's sometimes when I tell people this, they say that, oh, look, the CSRF tokens aren't on every page. They're like, they're in forms. You might have an injection in some page that's randomly out there, and at least you're not going to be able to do this there. But in reality, when you have a look at a lot of popular web frameworks these days, they seem to spray the CSRF token around pretty much everywhere. They'll put it in like meta tags, they'll put it in JavaScript, they'll just pretty much put it randomly so that whenever client-side code needs access to a CSRF token, it'll definitely be there. Anyway, so another directive that people often think is kind of not super necessary is a style source directive limiting which websites people can load style sheets from. Particularly, the typical style to script injection has gone away a little bit outside of IE. Like you can't do Moz binding anymore. But even those are less relevant without, unsafe eval on the JavaScript side. But one thing that's been known for quite a while is that CSS, actually CSS turns out to be like Turing complete with some animation craziness and some server-side stuff. But one of the things that people found out was that CSS has this thing called selectors, where you can essentially search the page, and you can search it with this kind of globbing matching. It's not really regex. It's just does this tag attribute have this letter, this character in it, or does it begin with this string, or does it end with this string? And if you can inject enough of these, selectors into a page with a style sheet, you can often leak the values of CSRF tokens no matter where they are on the page. I don't have internet, so I'm not going to try and run this demo, but this has been up there for like 5 years now, and the slides will be up there, and you can click yourself, and you can see that it's possible over like some amount of time, but over 25 seconds, you can leak 6 characters without script, and this hasn't been optimized in forever, so you can probably get better performance in your stealing if you try, but this is what was written back then. So Font source. So this is, in case you haven't noticed, this is just going to be a laundry list of directives and what happens if you don't enable them. To start with, the font source directive is a little bit complicated. The main thing that you can do with font source is you can include SVG fonts, and SVG turns out to be the real problem. I'm not going to go into detail since that's like an hour talk by itself. But if you look up Mario Heidrich's paper, you'll notice he's got a couple of interesting things. He's got a way to detect when you actually press keys, and also a way to leak the contents of the page by essentially serving up fonts where different characters are different widths. You can reconstruct the page by kind of looking at whether the scroll bar is present and some other really crazy stuff that it takes a while to explain. No. Object source. This one's kind of obvious. If you allow people to include objects from arbitrary locations, you can instantiate Flash, Reader, Silverlight, Java, etc. And then they have APIs themselves that can just directly call JavaScript and bypass the CSP calls because they call directly into the engines, not through the renderer. Anyway. That's kind of what happens if you have an incomplete policy. You get all this badness. I'll get to the more interesting stuff in a second. The main thing people bring up when they talk about CSP bypasses, the first thing that they mention is JSON-P. If you've done any kind of web application development which requires cross-domain data sharing, this is one of the things you'll probably stumble on fairly quickly. The idea is that a website can expose data as JSON by having this endpoint where the user provides a function in this callback parameter. It's usually like CB equals, and that gets injected into the start of the response as the function that's going to be called with this JSON blob. So what you can pretty trivially do is if you've allowed if you have JSON-P on your domain, an attacker can pretty easily make this script point to that JSON endpoint and say, hey, the callback's actually alert1 or whatever your actual payload is, and then an A. And your domain will end up serving that back as JavaScript, and you can pretty trivially run JavaScript in there. The other thing that you get onto after that is that you find JSON injections some of the time in applications, at least more often than JSON-P in popular web applications. You find that people don't take JSON injection particularly seriously since exploiting it is often impossible or at least impractical, but also because there's no direct risk of XSS, so these things stay unfixed for quite a while. And if you can inject data into JSON, since it's often served back as valid JavaScript, you can point your XSS at this JSON injection and have an injection of quote plus alert1 quote, and have that fire when you break out of the JSON context. I never got around to fully testing this on Firefox, but the script encoding stuff does work on Firefox. The question is about whether these character sets do. But if IE does ever get around to implementing CSP, which I'm kind of hopeful they will, there's like these additional issues with JSON encoding where you can say, hey, this content is actually UTF-7, so treat it as such. So if you inject this like plus ACI, minus, minus, etc., not these quotes, just this UTF-7 blob, and you tell the browser to pass it as UTF-7, it'll end up firing an alert as well. Yeah. One of the slightly less obvious things that you can do on an application-specific level is if you have image uploads on your domain that you've trusted as a source for script, an attacker can upload a valid GIF or a bitmap file that is also a valid JavaScript file. And JavaScript parsers are pretty strict, but they don't verify the MIME type of the responses they get. So even if they get a PNG or GIF MIME type back, they'll still go, oh, I'm going to try and pass this as script. And there's resources online where you can see like GIF and BMP, kind of like chimeras, people call them, where essentially you keep the header tag in place and then you put in some valid JavaScript afterwards. And you can pretty trivially bypass CSP if you have this kind of pattern. One of the, I guess, more theoretical things on this deck is going to be, when you say I'm going to trust all the scripts from your domain, that doesn't mean you've just kind of like solved it, even if they're limited to that. Those scripts do something. Oftentimes, as I'll go into a bit later, these things go and pass things from the DOM, and those scripts can go and do dangerous things, especially if you have the unsafe eval option of CSP turned on, where you allow JavaScript to actually call the eval command. You'll find a lot of scripts take tainted data from somewhere and then eventually stick it into an eval string, and that can be a way to bypass CSP. Another thing people bring up when they talk about CSP bypasses is content delivery networks. If you take JavaScript from a CDN, often this will be like if you take it from like jQuery CDN or Google's Ajax API CDN, you're going to be trusting all the scripts on that domain. With Akamai, you're often sharing that domain that you're trusting with a bunch of different people on that same CDN. And if someone gets onto that CDN, possibly legitimately, but potentially by just hacking someone else, they could upload script onto that domain as well. So this gets relevant when you have JavaScript frameworks in the picture. They're, as far as I can see, becoming more popular. I'm no web developer, but from what I see, these things are kind of taking off a little bit. People are building whole applications inside JavaScript, potentially on a single page. And one of the things they're using are these JavaScript MVC frameworks, or JavaScript's templating engines. And these things have templates that look like this, where you can essentially just shove JavaScript right into the middle of them. And you'll notice this has no script tags. This doesn't have anything that a browser would normally execute. But these JavaScript frameworks go through the page. They look for these things that they know are their own templates, and then they either stick them directly into eval or try and pass them and have their own kind of JavaScript execution environment. But I'm not sure if I mentioned this yet. So I glossed over it, but most of these templating engines can't live without unsafe inline. So the only one I found that can actually live with it is AngularJS, and I'll go into it in a second. But most of these listed on this page just end up chucking the contents directly into an eval call, and so you just trivially execute JavaScript if they're using any of these JavaScript templating libraries. Sometimes, again, back to the fact that they can't live without unsafe eval. Sometimes you just end up with just an injection into an eval that's not necessarily meant to be there, but because of slightly shady code, you end up with ways like this to execute script. Most of the stuff about JavaScript frameworks, these couple of slides come from this Mustache security wiki that I've got linked in the references that you can have a look at, which has much more detail about exactly what these frameworks are. But most of them kind of end up either directly passing into eval or giving you an object that you can then do things to. In this case, these are slightly tricky JavaScript tricks. In the second one, you end up getting the constructor of an object, which is a function, then you get the function constructor from it, and you pass in some JavaScript into the function constructor, which gives you back a function, and you call it. In the first case, you bind alert to window and call it again. These things are kind of typical patterns that you see when you start looking into kind of JavaScript tricks you can play, and they're fairly reusable among a wide variety of JavaScript frameworks. And I kind of want to talk about AngularJS a little bit more in detail, since it's the only one that actually does something to support CSP. They have this ngCSP directive where they use their own JavaScript expression parser and evaluator that doesn't actually execute JavaScript. I don't think I have a non-attack version of what an expression looks like, but they parse and execute this without ever actually calling eval by going, oh, okay, this is, we understand this is an object, this is a property access on that object, this is another property access on that object, this is a call, etc. So Angular decided that they were going to, Angular, like many JavaScript frameworks, all the ones I've seen do this, they decided to use native JavaScript objects as their object model rather than having a typical sort of programming languages approach where you hide the underlying model from everyone and only provide user created members and functions. But what this causes is that you can access functions and members of objects that that are not necessarily intentionally there. They're just there on every single object. So until like I think I don't know which exact version. I think like 1.1.5 they finally fixed this in stable. But until then, you can inject this string anywhere in HTML of a response that was being passed by Angular and have it execute like an alert one. This is a bit less relevant if you do use the ngCSP directive, but there's a couple of other things that have that I and other people have found that let you do functionally equivalent things. One of the less powerful things you can do that's actually still there by design and isn't going to get removed is they have this ng-include directive, which I kind of wish I had my demo up for, but they have this ng-include directive where you can say, hey, go to this URL, fetch the response, and stick it into the body of this HTML element. So if we attach this ng-include directive to a text area tag, we can get the response from that page stuck into the text area tag. And as I mentioned, a couple of slides back, if we get like some sensitive content into a text area tag, we can get it submitted cross-domain to an attacker. So this is another way we can use to leak CSRF tokens. But oh my god, damn corporate laptops. Anyway. But another one of the consequences of using native JavaScript objects as your object model is that if you ever end up with a reference to a window object somewhere, it's kind of game over. This is a bug that got fixed in 1.15, but the event object had a view property on it, which was just the document window. So when you clicked on this body tag, you would you'd receive this $event object that you could then get access to the window object from, and you could start calling arbitrary functions on. This example isn't necessarily very illustrative, but in terms of JavaScript sandboxing, you don't want people to get access to the window object specifically because it has the document object coming off of it, and document has cookies, and it has the get element by ID function, and it lets you get access to pretty much everything sensitive from an XSS context that you'd want. So despite this not actually running any JavaScript if you have the ngCSP directive included, this goes through their evaluation engine and actually ends up calling those functions that you'd want on your behalf without actually ever evaling this. So you end up with a fairly trivial CSP bypass that still looks pretty much like JavaScript. But yeah, so as I mentioned with CDNs, these things become a real problem for you because of these exact bugs in JavaScript templating libraries. They end up hosting pretty much every single version of a JavaScript framework on the same domain. So if you ever allow ajax.google APIs or code.jquery, an attacker can inject any old version of your APIs into that page. So if you're using Angular and you're using a version later than 1.15 and this has been fixed, but you're using a CDN to get that to get AngularJS, an attacker can still inject a script tag to an Angular 1.08 or something that still has this bug and bypass CSP that way. Anyway, that's kind of the JavaScript side. Yeah, Angular CSP seems to be kind of the best. They're actually taking care of these kinds of bugs, and it's why it was more interesting to pick on them. But all the other ones have still these kind of very trivial ways to bypass CSP by injecting things right into eval. But anyway, on the browser side, one of the things people often do when implementing CSP is they use this default source directive, and they say, oh, default source is self. We don't want We don't want people making tags that point cross-domain and doing all this dangling markup stuff that that leaks information to attacker websites. A particular problem with this is that this doesn't actually end up covering everything. It ends up covering the things that all the other directives cover, and it encapsulates them in one configuration option, but it doesn't necessarily cover absolutely everything in the browser that actually makes requests and lets you leak CSRF tokens across domain. The particular one that's probably never going to get fixed is, if you inject a half-open link, if a href equals quote HTTP evil or whatever, that essentially, if you can do some clickjacking afterwards or get the user to just click on that link, they'll end up leaking CSRF tokens. But this kind of thing is probably never going to get fixed in the in the specs, since it's kind of impractical for most websites to whitelist where they're going to link to. But on the actually more useful to an attacker side, you can inject, when you spell this correctly, you can inject a meta refresh tag that will, once it's rendered, will go and will load the user to that page, and you can leak the contents of the CSRF tokens that you're interested in that way. There have been other things proposed. I think this one was proposed by Gareth, where you inject some HTML that causes the sensitive data that you're interested in to be loaded into a JavaScript object that's accessible across domain. So in this case, you inject a base name property, and then you can, from another site, which is actually trying to attack this one, you get a reference to that window object, and you can actually read the name property directly, regardless of the different origins, and you can leak CSRF tokens that way. One of the things that's not covered in the spec at all is you can set cookies. So we can perform session fixation attacks that never really got fixed in most web applications. As far as I can see, session fixation got fixed by fixing all the containers to make sure that you couldn't trivially force a user to use your chosen session ID. But we never actually fixed the underlying bugs where web applications wouldn't regenerate a new session ID on login. So we can still perform these kinds of attacks. How am I doing for time? 4:16, right. So when I mentioned that those issues with the text area tag, where you can inject a text area or get content directly loaded into it, the main thing that we have kind of in an experimental mode at this point to stop this is this form action directive. It's meant to stop a bunch of stuff like phishing, password managers attacks, and the kind of form-related issues we've looked at earlier. But this only stops us directly leaking data across domain. If we take the form that we've injected with our text area tag, and instead of pointing it directly cross domain, we make it a GET request, and we point it right back at our XSS. And in our XSS, we include something that causes a navigation or request somewhere, for example, a meta refresh to our site. We'll get the form contents leaked to us via the referrer header. And so we can bypass that one. Yeah. Object source self. This one, as I mentioned before, if you can load arbitrary Flash files, you can run arbitrary JavaScript regardless of CSP. And the browsers have all made a decision not to follow redirects when doing their validation here. So if you find an open redirect anywhere on the domain, and that domain is in the object source whitelist, you can just point it at that open redirect and have that go to your domain and load a malicious Flash file that then calls external interface. When I was looking at trying to bypass this particular one, I thought they would have followed redirects, and this would have been actually interesting. But the thing I wanted to call out is that if they ever do try to pass what happens with open redirects, they face the kind of this parser differential problem, where if they pass HTTP responses differently from the plugin, then there's going to be a mismatch between what will be requested by the two. So if you could see an example where the browser's location header passing code says, oh, this is an invalid URL, but the plugin's passing code says, oh no, I know how to deal with this. You could potentially, again, have a situation where the browser goes, oh, this is going to be fine, this is just a request from this domain, but when the plugin goes to retrieve it, it goes to the attacker's domain. Not relevant yet, but potentially relevant if they try to harden this attack surface a bit. So with font source, I kind of was a bit lazy. The main thing that I mentioned we're interested in before was actually not the fonts themselves, but the loading of SVG. And Mario noticed again that since SVG seems to be his little playground, that in Firefox you can actually have inline SVG tags that aren't blocked by CSP, and you can do all the typical data leakage or keylogging things that are in his paper. And you can effectively bypass the interesting restrictions that font source has by simply injecting SVG directly into the HTTP response. So with style source, if anyone's ever played with CSS, you might have seen that CSS parsers are really extremely forgiving. So when they try to pass, a block of data, they needed to be, when they were designed, they wanted them to be forward compatible, so that if they saw something they didn't recognize, they would essentially just skip over it. So that when you try to use a new feature in your CSS file, you didn't just break every single old browser. So to do that, they ended up introducing this reparsing behavior. If they ever, it's a bit more complicated in the exact implementation, but from an attacker's point of view, if a CSS parser ever sees open curly brace, close curly brace, then it kind of just says, okay, I don't know what everything before this was, but at this point I'm going to start trying to parse CSS again. So if you can inject this string anywhere in a response and point to it, a CSS parser will treat that as valid CSS no matter what is before or afterwards. So combine this with the fact that CSS parsers don't check content types like JavaScript parsers. What we can actually do is we can inject these kinds of strings into our XSS response. So we can have this kind of two-level injection where we inject a style tag pointing at our injection again, which injects the CSS we're interested in, and have that CSS run. And then we can do the things I mentioned before, where we load up selectors and leak out the contents of CSRF tokens that are on the page. If you have image source tar or something, then it's fairly trivial to leak it out. You just do what was in the demo that I have a link to, where you just make background image requests to the attacker site saying, hey, the first character was A, maybe the first character was B or whatever, or like the first two characters were A, B. But if that's restricted, there's several things to do. If you can do these kind of scroll bar tricks that again are in Mario's paper, which everyone interested in this should read, or you can influence the height of things via CSS, and then and the height turns out to be another one of these properties that can be read cross domain without any origin checking. And this might actually get a little bit more interesting sometime in the future. Chrome Canary supports this, but no one else, so effectively no one. But there's this seamless attribute that there's a standard for in iframes, where all the style of a current page will be applied to the child iframe as if it was part of the top-level document if you provide the seamless attribute. So if you ever have a case where you have an injection but you don't have a CSRF token on that page that you can leak, you'll be able to just include an iframe with the seamless attribute pointing to a page which actually has a CSRF token that you want to leak out. This is kind of funny. If you're looking for a kind of a side channel to leak out your data and you don't have image sources star, then one of the things you can do is you can specify a report only policy in Chrome via a meta tag. And you can point this to a third-party domain, and all CSP violations, all these reports that are meant to be kind of IDS-like will go to your domain instead of not instead of, if they don't have a policy, you can inject this and get all these violation reports. So if you provide a policy that's super restrictive, you say, I don't allow requests anywhere, then you'll get a JSON notification on every single URL that's in the page. So besides being an easy side channel, this is also actually a really easy way to leak out CSRF tokens if they have some kind of automatic rewriting happening where it gets attached to every single URL. So if they're attaching CSRF tokens, for example, to images, you can attach your report-only policy that violates on everything, and you can get these CSRF tokens leaked back to you as JSON requests. So you might not need bypasses that are at all complicated, since the state of these implementations is a little bit poor. In Safari-based browsers, you were able to inject this. This has been fixed now, and actually the two bugs that I wanted to show have been fixed now. But they both kind of illustrate the immaturity of these implementations. In Safari, you were able to inject this base href tag that would cause all your requests to be resolved relative to this. So including all your script tags would be resolved relative to this. And if you had script source equals angular.js, that would start coming from attacker.com, and CSP wouldn't register it. In Firefox 10, 11, and 12, they somehow just had a regression that got rid of any kind of checking on this code path. I think I missed this other Firefox bug that got fixed like in the last release, where if you attached a sandbox attribute to an iframe, then that iframe wouldn't have CSP applied to it, since they didn't set up the principles or something properly. Anyway. So that was kind of a bit of a brain dump, but the summary of the directives themselves is that there's a lot of parts that work, but a lot of parts that at the moment aren't really doing their job. And some of these seem fairly hard to fix. In particular, the style source issues where you get to inject a style seem hard to fix without breaking parts of the web. It might become a CSP directive at some point to say, hey, I want to validate the content type of my CSS, but at the moment we're not there. And the issue with open redirects on object source is kind of gonna stay there until browser vendors and plugin makers kind of make nice. And besides kind of these general bypasses that let you leak CSRF tokens or execute script, we get these other capabilities that are not directly XSS, but often let us construct an interesting exploit regardless. We can set cookies, we can leak page contents. If anyone tries to use the origin header as a CSRF protection, as people have been kind of advocating a little bit lately, then you can trivially bypass that once you have an XSS, even if you can't do anything quote-unquote useful with it. If you're a sophisticated attacker, you could actually still use this to launch typical browser exploits. I know people were interested at one point in buying XSS exploits for webmail services, simply because they wanted to then launch their own browser ODE from there, and they wanted a convenient platform to do it without having to force users to click on links. So despite not actually being able to XSS anyone with payloads like this meta refresh, it's still enough to actually start running JavaScript and running potentially browser exploits. But all is not completely lost. A lot of the stuff, either when you have an incomplete policy or some of these things related to styles or SVG fonts, they're very heavily related to leaking data that's on the current page. And often, leaking CSRF tokens, since these are small bits of data that we can leak to gain some significantly bigger benefit. These CSRF tokens don't actually have to be on the page itself. They don't actually have to be in the HTML response. If you're writing a JavaScript web application, you can fairly easily store your CSRF tokens in session storage or in cookies or something else that's much harder for a scriptless injection to get access to. And if you want to really use CSP, I'd recommend looking at locking down that part of have your CSRF defenses to make these bypasses a lot harder to use. The other thing that's coming that could make people's lives a bit easier is this script nonce directive in CSP. The idea is that if you provide a nonce inside the HTTP response that is random, and you include it in the an attribute of a script tag, that script tag should be trusted no matter where it's pointed. This lets you kind of more easily migrate to CSP, but it also lets you have much more fine-grained control over what content you will and won't allow. So if you're worried about issues with CDNs in particular, once this script source nonce, or maybe the script source hash thing, when either of those two things land, you can potentially not whitelist your CDN domain, but you can put nonces or hashes to these specific calls that you know you've added yourself that are trusted. And then you have your typical session fixation defenses that you want to look at when you realize that attackers can still use XSS to set cookies. And then, anyway, yeah. I think I might just open up the floor to questions, since most of this is just wrap up. Anyway, does anyone have any questions? Yo.
Have you looked at the AngularJS while you
No, the JavaScript, I only really spent time looking at AngularJS. Mario's mostly been looking at all of the other ones that. Yeah, 1.1, I think. I saw a patch to Google Chrome that had the script hash stuff implemented. So the versioning seems a little bit irrelevant. People are just implementing it piecemeal, however they feel like. So I wouldn't put much distinction between CSP 1 or 1.1 at this point. Anyone else? All right, I guess we're done. Thanks, guys.